Good morning, everyone. My name is Timothy Lee Grant, and I wanted to make a video about what I think artificial intelligence is. So, last video, I talked about how I am just starting my adventure into the field of artificial intelligence. I have been going to school for a while. I'm a senior in the electrical engineering program at Oregon State University, and I've done all of the prerequisite math courses, all of my circuit analysis, signals and systems, electronics, all of those, the assembly language, all of those under uh, basic classes. And I feel strange calling them basic, but anyways, I've done all of those, and then I knew that I kind of wanted to specialize in artificial intelligence and machine learning. So I took some of the other required kind of classes. So, for example, I took statistics, and I'm taking linear algebra right now, and a few other classes. So I tried to put myself so that I could go into this tract. And I am currently, right now, in the machine learning course at OSU. And I thought it would be interesting to do a video talking about what I think machine learning is, and then compare it to what I find out about it. So, essentially, what I think machine learning and artificial intelligence is that it is a way to take in data and get a prediction. That's it. That's the entirety of what machine learning is. So you have this data set, has whatever the data set is. So it could be like US Census data, or it could be on YouTube that this user clicked these videos, the watch time. So all of these would be like attributes of a single person, right? Watch time videos, the type of videos that they watch, right? So that's one person, and then you have, I don't know, a billion users, right? So, or this video that I'm making right now is also an input, right? So what I am speaking is input. It's audio, sound, and you're able to take that, decompose it, and then try to analyze what words are going on. So you have data, some different types of data. It doesn't matter what kind of data, but you have data, and then you have an algorithm that creates a prediction. So that is what is so varied in the field, is that, for example, if you have census data, it's fairly easy to kind of structure it, right? You have age, you have gender, you have all of these different structurings in the census data, and you have all of the entries. It's very nice and neat. And then you can have this algorithm that tries to make a prediction on whatever it is. I guess you could take that and then try to merge it with maybe medical records, although medical records are kind of secretive. So if there was a public database of medical records, you could try to merge that and then try to make a prediction based on different attributes, the age, the income, all of this, if the person is going to get heart disease or something like that. So it's taking on inputs, processing it in some way, and that's what machine learning is, and it gets an output. But I think it's going to be very difficult because there should be many different ways to process the data. And as I said with the US Census, that's very nice, neat, organized. What if you don't? So I said that I've done signal processing, right? And I'm just thinking about, I'm making this video, and there's a whole bunch of noise. There's my voice, but there's also maybe the traffic. I don't know if that's picked up, but that's going to be there. There's static noise. There's random noise. There's all of this. So how do you classify? So the input would be the audio signal. Then the output, well, in that case, I'm not even sure what the output would be. I guess you're trying to get a algorithm that is able to predict the words that I'm saying. So you would have to, you could decompose the signal into frequencies, and then you would also have to figure out how to stop it, though, right? Because when I speak, if you listen to me, I don't talk like this, where I'm talking in a very rhythmic way, that there is a differentiating silence between each word. When I talk, I kind of talk in a continuous pattern. So how would you analyze each and every word? You would need to have, man, that's crazy. Just thinking about this. So, um, you, yeah, but the input would be the audio that's coming in, and then the prediction or output would be the words, the individual words that I'm saying. And so then what I think might be able to do is take one algorithm, one machine learning algorithm, and string them together. So then you could have the output of this audio analyzer algorithm, machine learning algorithm, my video is an input. This machine learning algorithm does an output, which is the words that I'm saying. Okay, now it does this for every single video on YouTube. Okay, so now you have one algorithm that gives an output, and now this output can be categorized as a data set as well and fed into another one. So maybe that's looking at what topics are trending, or what gets the most clicks, or all of these. One algorithm creates an output that this output is able to be conglomerated into a secondary data set, which that data set is then able to be fed into another machine learning algorithm. And so in this way, you're able to string algorithms together in order to create a more and more varied system, that you're able to do more tasks. So that's what I think machine learning is about, and how artificial intelligence works, is that it is an input output that you string together and are able to create really complicated predictions, I guess, outputs, by stringing them together. And I think that's what we see when people talk about how amazing artificial intelligence is. I think it's probably because it is so not abstracted. It is so complex. It goes from one algorithm to another, and all of these different algorithms feed into other ones and are able to do these really amazing, complicated things. I think that's what's going on. And I think that is what machine learning is really about, is trying to figure out what models to use. And then also, the other really big thing that I think that machine learning does is in terms of how to structure the data. So I mentioned that with the census, and then with the video, okay, so it analyzes my voice, and it can detect each voice. By the way, it can already do that. If you press, I don't know where on the video it is, but you see auto captions, right? I didn't do that. YouTube did that. So it can already detect my voice. It can already detect the actual individual words that I'm saying. But anyways, so it comes out and goes into this other data set of, this is my video, and these are the words that I said. And then this is another person's video, and those are the words that are said, right? So how do you structure this? You would also need a way to, you would need to know the view count maybe, or the impression count, and all of this information per video, that you would get more and more attributes to that individual entry, right? So the words that are said, then the number of views, then all of this. So you're adding more and more information, more and more attributes to each entry, and then you're getting more and more entries every single time a new video is uploaded. And now, how do you structure that data? That would also be a fairly difficult task. And I think that that is really big in machine learning. Like, you have to have what models you use, how you string them together to create a really powerful output, and then also how to structure the data. So that's my opinion. That's what I think machine learning is without having any experience, without knowing anything. And let's see how close to reality I am once I start getting into the field more and more. So yeah, if you like this video, please subscribe and you can join my journey towards machine learning and artificial intelligence. Thank you so much for watching. My name is Timothy Lee Grant, and I will see you guys next time. Bye.